Good morning, everybody. I'm Mahima, saxena, Assistant Professor in Computer Science Department from AKGEC. Today, I'm going to present my lecture on decision tree. Decision tree is a supervised learning algorithm. In supervised learning algorithm, we use labeled data. In previous lecture, I completely explained what is supervised learning. Now, I'm going to start my lecture on decision tree. Decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problem. It is a tree structured classifier where internal nodes represent the feature of a data set, branches represent the decision rules, and each leaf node represent the outcome. If a decision tree In a decision tree, there are two nodes, which are the decision nodes and leaf node. Decision nodes are used to make any decision and have multiple branches, where leaf node are the output of these decisions, do not contain any further branches. Decision trees or the test are performed on the basis of features of the given data set. The graphical representation for getting all the possible solutions to a problem decisions based on given conditions. Decision tree, it is called a decision tree because it is similar to a tree structure. It starts with the root node, with which expands on further branches and construct a tree like structure. In order to build a tree, the use of cart algorithm the we can use cart algorithm, classification, association, regression technique. A decision tree, basically a decision tree is a tree like structure based on classification data. Classifications data are classified as into categories like yes, no, male, female. It is a binary category or ternary category or more category. It does not specify any range. This is a structure graphical representation of tree. Basically, on the first, the decision node, we call it a root node. Then further we specified its branches, and then a subtree is formed: decision tree, decision node, leaf node, etc. Decision tree terminologies. Root node is from where the decision tree starts. It represents the entire data set, which further gets divided into two or more homogeneous sets. Leaf node are the final output, and the tree cannot be segregated further after getting a leaf node. Splitting is the process of dividing decision node, root node, into sub nodes according to the given conditions. Branch, subtree, a tree formed by splitting the tree. Pruning is a process of removing the unwanted branches from the tree. Parent, child node. The root node of the tree is called the parent node, and the other node is called the child node. Advantages of decision tree: it is simple to understand as it follows the same process which a human follows while making a decision in real life. It can be very useful for solving decision related problem. It helps to think about all the possible outcomes for a problem. There is a less requirement of data cleaning compared to other algorithms. Disadvantage of decision tree: the decision tree contains lots of layers, which makes it complex. It may have an overfitting issue, which can be resolved using the random forest algorithm. Random forest algorithm is based on categorical data. For more class labels, the computational complexity of the decision tree may increase. Now I can explain the decision tree numerical. This is the table. This is we have 6 attributes. The last one is the class attribute. In question, generally we have given that last as bias computer is a target attribute or class attribute, but if it was not given in the question or not present in the question, then we will always choose the last attribute, bias computer. First formula is information is equals to minus summation m I equals to 1 pi log base 2 pi. This is the formula of information gain. We will calculate the information gain of each and every attribute. First, we will calculate the information gain of class bias computer. With the help of formula, we have 9 yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 yes and 5 no's. Because of that, we put the values of yes or no in that particular formula, and we calculate this information gain. 9 is the values of yes and 5 is the values of no. According to the formula, we put the values and change the base, and then we can calculate this information gain. After that, this is the information gain of whole table of 14 iterations. In the next, we will calculate the information gain of age, income, student, and credit rating. In age, we have 3 attributes, basically youth, middle age, and senior. In youth, we will check with respect to class attribute, that is Bayes computer. In youth, what are the values of yes and what are the values of no? What are the values of no? Basically, in youth, we have 5 youths, and 1, 2, 3, 4. We have 5 values of youth. From that 5 values of youth, we have 2 values of yes and 3 values of no. With the help of this formula, we will calculate youth, and again that's apply on middle age. We have 4 values of middle age, and with respect to that middle age, we calculate a Bayes computer in what are the values present in yes and no with respect to middle age, and same goes to senior. This is the particular formula, and we put all the values of youth, middle age, and senior. In youth, we have 5 values of yes. 5 total youth is equals to 5, and 2 are yes and 3 are no. In middle age, we have all the 4 values are present, and we have 4 all yes are present. We have no value of we have no zero value of no. Now in senior, we have 5 total values of senior according to the table, and we have 3 yes and we have 2 no. Then we will solve this formula, and we got the answer. This is the information gain for particularly age attribute. Now we will calculate for income, student, and credit rating. Now after age, we will calculate the gain. The formula of gain is, the first we calculate this information gain for class attribute. That class attribute is our Bayes computer, and after that we minus that from class attribute we minus the value of age. 0.938 minus 0.69. After that we got the value of gain. Now we will calculate same as income and same as student and same as credit rating. For income, we have 3 attributes: high, medium, and low. We have 4 values for high, 5 values for medium, and 4 values for low. After that we have yes. We will check high for in respected class attribute. 2 is yes and 2 is no. In medium, 4 is yes and 1 is no. And in low, 3 is yes and 1 is no. According to the formula, we calculate this. 0.75 is then. After that, we again calculate the gain. Same as this, we calculate this. Information gain minus information of income information of income. After that, we calculate this. The gain of this is calculated. Similarly, we calculate student for student and for credit rating. 7 by 14. 14 is the total number of iterations we have, and 7 is the students. Total number of students we have. 3 is for yes, no is for, 4 is for no. Again, 7 is for yes and 7 is for no. Basically, we calculate similarly in previous step we calculate, and after that we calculate gain. Again, we calculate credit rating. In credit rating, we have 3 attributes: fair, excellent. Sorry, we have 2 attributes: fair and excellent. For fair, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 values of fair. We have 8 values of fair and 6 values of excellent. Then again, we will put the values in the formula and calculate the gain. After that, now we will check the highest value of gain. We have 4 attributes, and among them the highest value of gain is age. Now we can assure that the highest value of the gain is our root node. So age is our root node because the highest value of gain has age. Now age is the root node, and we will split our tree according to the age. Now age has three attributes: youth, middle age, senior. Youth, middle age, senior. According to that, we will build a tree. This is our root node, and now we will further expand this tree. Now according to age, now according to this structure, we have 5 values of youth: D1, D2, D8, D9 and D11. Middle age 3, D3, D7, D12, D14 and senior D4, D5, D6, D10, D14. These are the values of our attribute youth, middle age and senior. Now youth is further, with respect to class attributes, youth is further divided into two parts, yes or no. Middle is not further divided into two parts. Middle is only divided into yes, and senior is further divided into two parts, yes or no. Now according to that, we will divide our tree into two parts. First, age, youth, middle and senior. According to youth, we have 5 iterations, and according to senior, we have 5 iterations more that are divided into two parts. Because of that, according to which we will further divide our tree. Now again, we will take these 5 iterations: D1, D2, D8, D9. We will take these 5 iterations, and according to that, we will repeat the whole process again and calculate the gain, entropy, information gain, etc. all the things, and after that, we will build our tree completely. Now we will take the value of first attribute, class. Of course, we have 2 yes and we have 3 no's. According to the formula, we will put the values and calculate the entropy of youth, which is 0.95. After that, we will calculate the entropy of income, which is high, medium and low. We will calculate high, medium and low. We have 2 values of high, 2 for yes or 0 for no, 1 for yes and 1 for no, and 0 for yes and 1 for no. These are the attributes, and after that, we calculate these attributes and put the value again. And again, we will calculate gain. Attribute student. For student, we will calculate again the repeat all the process of the formula. These are the 2 by 2 is the value of this yes, log base to 2 by 2. 0 is for 0 value because we have 0 yes 0 no values. Because of that, we will calculate this, and after that we will calculate entropy. Again, we will calculate for student, and again we will calculate for credit rating. These are the steps we will follow, and after that, our second iteration of tree is performed. First is age, second is youth, third is middle, fourth is senior. According to that, student has the highest gain. After that, we will divide into two parts, no or yes. Middle, we don't need to divide because middle only have yes attribute. It is further not divided in no. That's why we will not divide it into further attributes. After that, senior is divided into two parts. Now we will take the table of senior, and again we will calculate the value of class attribute, income, student and credit, and after that we will check whether it is highest gain is present or not. In this process, first we calculate the entropy, which is class attribute buys computer. Second, we will calculate for income. In income, we have medium and low. We have 2 attributes which is present. From 2 attributes, we have 3 of medium values and 2 of low values. Because of that, 3 is medium values and 5 is the total, and 2 is the low value and 5 is the total. After that, we will calculate the information gain, and from that information gain, we will calculate the entropy. Now we will calculate information gain for attribute student. In student, we have 3 yes and 2 no's. And we will calculate this with respect of class attribute. The entropy is 2 by 5 into 1, 3 by 5 into 0.9. We calculate this, and again we calculate gain and compare all the gains. We compare the gains of income, student, credit rating, credit with respect to class attribute, which is buys computer. This is the last step. Attribute credit rating entropy is equals to 3.5. This is the step for credit rating. We take values from there. We have 3 fairs and 2 excellent. Because of that, we have 3 fairs and 5 total values, and 2 is like entropy. 2 is excellent and 3 is fair. Because of that, we calculate the entropy as fair, as excellent, and gain. And now again we will calculate, and now again we compare the gain of all the attributes, and further we complete our tree. In senior, we have the highest value of gain is credit rating, and after that we further divide, because in credit rating we have only 2 attributes, excellent and fair. That's why we put there excellent and fair, and excellent is further divided into no, and fair is further divided into yes. This is the complete explanation of decision tree. Basically, decision tree is a tree-like structure which is based on categorical data. Categorical data is like classes. The data is divided into classes. It is binary, ternary. There is no hard and fast rule. It is only applicable on decision tree. Is basically a supervised algorithm. In supervised algorithm, we used labeled data. That is, we have input and we have output. We need to map correct input from correct output. This is called supervised, and after that decision tree algorithm is used. Decision tree is best for supervised learning. Thank you for today's lecture.